Hi everyone, and welcome to our last video in Unit 4, Solving Absolute Value Inequalities Part 2. As promised on our last video, this would be the second case. This is the less than. Notice less than. That's interesting. I wonder what that means. Yeah, these are all going to be less than. So less than or equal to, less than. Okay, so again, I write too big to write it on here, so if you're going to write it on here, that is absolutely fine. I'm going to come to a bigger sheet of paper here where I have plenty of space to think out my thoughts. So example 1, we're going to solve the absolute value of x is less than 4. So I got to talk myself through this, So the values, the contents here, the values that I put in here inside these bars, whatever number I sit here, its distance from 0. The distance from 0 has to be less than 4. I have to be less than 4 away from 0. Boy, I can't go very far, can I? But I also have to think of the two sides of the number line, the positives and the negatives. There are kind of two directions I can go. So if I was walking on a number line here, and I thought of 0, if my distance from 0 has to be less than 4, man, I could go out to 4, but boy, I couldn't go any further than that. I'd bump into that 4 and I'd kind of have to stop. And I could walk to -4 and I'd be okay. But once I got that far, I'd have to stop, because if I go beyond it, then I'm too far away from 0. I'm not less than 4 away. So I could go out to here and stop. So kind of anything between all the numbers that are sitting right in this little bubble would meet the requirement. Like if I would put a 1, like 1, right? 1, well, 1 is only 1 away from 0, and that's less than 4. That's good. But if I went out to like 6, I've gone too far. 6 is not less than 4. So when I'm forced to have my distance from 0 be less than a number, then I'm stuck between the positive and the negative of this guy. So from an earlier video, there are two different ways we could write the solution, but I'm going to kind of force us to do it in the more succinct, mature way. And that is this. All of my solutions, right? All of my x's, which are my solutions, all of my x's are stuck between -4 and 4. And they have to be less than 4 for sure. I can't go beyond 4, so I have to be less than 4. But at the same time, I have to stay above -4, greater than -4. So in my mind's eye, I'm thinking of this, like, okay, x has to be greater than -4. But because I'm writing it like this in one line, and the x is on the opposite side as it is here, I turn this around, put the x on the right, the -4 on the left, and I switch him so he's going to point left. And ta-da, I've got my answer. Cool. Let's check out the second one. Example 2, very similar. It says the absolute value of x has to be less than or equal to 2. Less than. Think about it. You're less than 2 away from 0. That doesn't give you much wiggle room. Here is 0. Your distance, the numbers that go in here, cannot exceed 2 in either direction. So like you can go to 2, that's fine, but don't go past it. And by the way, this one can be equal to 2, so I'm going to fill that dot in. So you got to stay there with the 0. And then -2, fine, you can go out that far, but no further. Your distance from 0 must not exceed 2. It can be equal, but must not exceed, so you can be in here between -2 and 2. And so that gives me this solution. The x is between -2 and 2. Cool. And you've got to be less than the +2. I'm sorry, less than or equal to the +2. But greater than or equal to the -2. So we face it this way. If you turn this guy around 180, it's going to say your x's are greater than or equal to -2. And now we're between. See how it's getting easier? The last one, a little bit more complicated. It just has more stuff around it. So let's take a look. We've got the 2 on the outside times the absolute value of 4 minus 2x, and then minus 3 is less than 15. Okay, cool. So again, I don't like to interpret anything with a number line until my absolute value bars are isolated. So I'm going to go ahead and do that. I'm going to get the 3 over and get rid of this 2. So let's start by adding 3 to both sides, which will give me 2 absolute value 4 minus 2x is less than 18. And then just like the last video, I'll divide by 2 to scratch that off. And then I'll have the absolute value of 4 minus 2x is less than 9. And this is much easier to work with. Now, what I've got, the contents of my absolute value, this whole sort of expression, this 4 minus 2x, right? It can't be more than 9 away from 0. It's less than 9 away from 0. It's less than 9 away from 0. So it can go out to 9, okay? Like it can go to 9. That's cool. But no further. And you could stretch it back to negative 9, but no further. So the contents must be between negative 9 and 9 in order to keep our distance from 0 less than 9. We can't go any further than 9 in either direction. So I'm going to say that my 4 minus 2x, okay, my 4 minus 2x has to be underneath 9, no further than 9, but it's got to be above negative 9. Okay, so this is what we have. Now, when we did this up here, it was all said and done because x was alone. Now, x is not alone, but we have to get it alone by algebra. So you can actually solve this compound inequality altogether. You can just leave it as it is. We just have to get x alone. Now, what I want you to do is, if I cover this part up, okay, and it was just that. If you were just looking at that half, 4 minus 2x is less than 9, and I wanted you to solve that for x, how would you do it? Well, hopefully you're saying I minus 4 from both sides, right? Minus 4 here, minus 4 here. Well, guess what? That's what you do. But you do a minus 4 here, you do a minus 4 here, and then you come over here to the negative 9 and you also do a minus 4. You have to keep balance all 3 slots. Okay, so what does that give us? Well, that's going to give us negative 9 minus 4. That's negative 13. Bring down the less than. These knock out. Bring down the negative 2x. And bring down the less than. And then 9 minus 4 is 5. Great. Okay. So what comes next? Well, again, let's cover that up. What would you do if it was just this right side? Negative 2x is less than 5. What would you do? Well, hopefully you're thinking you would divide by negative 2 on both sides. So that's what we're going to do. We're just going to also do it over here. So we're going to divide by negative 2, divide by negative 2, divide by negative 2. And so it's not going to be the prettiest. Negative 13 divided by negative 2 is 6.5. So I'm going to say 6.5. Now what happens when I divide by a negative? When I have an inequality? I have to turn the symbol. So greater than. These knock out. X. Again, dividing by a negative. So flip it. And this is negative 2.5. Now, that is the answer, but I don't like it. I prefer, first off, I don't like these symbols pointing right. Even though it's correct, I don't like it. And I don't like the higher number being here and the lower number being here. So I'm going to completely peel this and flip it around. So the x will stay in the center. That's great. But I'm going to shush the negative 2.5 over here. And I'm going to shush the 6.5 over here. So that means if I'm going to turn those around, I've got to turn these back around. It's a lot of flipping of symbols. The original flip here to here was done because we divided by a negative. That's just that inequality rule we know. This flip is because I'm rearranging these two numbers, so such does the signs have to go too. Okay, so now we have the solution. This was all done algebraically, right? So I want to see, so all of my x's, right, have to be between negative 2.5 and positive 6.5 in order to make, if I checked it back here, to make a true statement. So what I want to do now is I want to see if I can get the same answer visually on the calculator. This is so cool. So get ready for this. Okay, so what I'm going to do is bring my calculator over. I want you to clear out anything that's old, okay? And we're going to stick the left side of the inequality in here. And I mean the original, the ugly one, the 2 with the absolute value, the whole kit and caboodle. So I want you to type a 2. Then came the absolute value. So math, num, abs. And then came 4 minus 2x, kick out, and then a minus 3. That was the entire left side of the original problem. The right side was simply 15, so we'll go ahead and type 15. Now I'm already contemplating a window change because this 15 is going to draw my y max higher than 10. So let's hit window, and I'm going to come down to my y max. Let's make it 20, just so we're above that 15. And graph. And we're seeing a V, and we're seeing our horizontal line at 15. So let's grab our edges. The points of intersection would, of course, be the edges. We always have to get those, because then greater than would sit above those, less than would sit below. So let's go ahead and grab those. So we have to do a second trace, intersect, enter, enter, pull left, enter. Now I'm getting negative 2.5 here. So again, I like to sketch this down on my paper. So before, I'll bring this back in a second. But what I got so far is, this is looking like, let me move this up a little bit here. Oh, I can't. This is taped down. Shoot, I'm drawing on my wrong paper. Let me get another piece of paper. This is looking like, bear with me, technical difficulties. So if I graph what I'm seeing on my calculator, I'm seeing this V coming down here like this. Doesn't have to be perfect. I see y-axis is here, and then I see my horizontal line coming through like right here. And this right here, right, is negative 2.5 from what I've gathered so far. Okay, great. Now, off to get the other guy, this guy. So I have to do it again. Second trace, number 5, enter, enter, pull right. And enter. And I'm getting 6.5 for this guy on the X. Okay, so that means this guy right here is 6.5. Now, I'm feeling really good about that because of my answers. Where are they? Because look, negative 2.5 is the low end, 6.5 is the high end, and if I did this correctly, my solutions are in between them. Well, let's see. The original problem read as follows. It said 2 times the absolute value of 4 minus 2x minus 3 had to be less than 15. So I'm looking for where the V shape is below, less than, the horizontal line. V, below horizontal. And so I'm thinking that would be here. And all of that red is indeed between here and here. So I'm feeling really good about that. Awesome. And if I pick something in between here and here, by the way, I don't know, let's use something easy to work with, like 0. 0 is between there. That's in the red right here. So if I would put 0 into this original problem, I would put a 0 right here. That means I should get a true statement. Let's check it. That would give me 2 absolute value. 4 minus 2 times 0, well, that's 4 minus 0, which is 4. Minus 3 is supposed to be less than 15. Next, I have to evaluate the absolute value of 4, so I have to ask myself, how far away from 0 is the number 4? And it is 4 away. So this is 4 times the 2 minus the 3 has to be less than 15. 2 times 4 is 8. 8 minus 3 is 5. And 5 is less than 15. So that's a good one. So that's making me feel really good. So again, coming back full circle to the beginning, it looks to me as if there is a bit of a pattern like on the last lesson. So when you're dealing with less than, it keeps you trapped between the positive and negative version of this number. Notice here my x, my contents are trapped between negative and positive 4. Here my contents trapped between negative and positive 2. Here, once I had the contents alone, the contents were trapped between positive and negative 9. So you see a pattern emerging there, but hopefully that pattern is built from something making sense to you. So you're going to go for the mastery. This is the last official mastery in the packet that's not review. The review's at the very end, but this mastery would come next. I'd like you to do the algebra by hand like we did, and then check it on the TI. Look to see where your V shape is below these different numbers or equal to. Okay, thanks for watching, and I'll see you next time.